Seeing Eye Drone, a system to help the visually impaired with mobility. Seeing Eye Drone is a drone-based computer vision system using 2D and 3D to assist the visually impaired with mobility, much like a seeing eye dog. Unlike the dog, it can actually tell the user what the obstacle is. Deep learning is applied in a mobile application, processes and receives data, and communicates with the user. It can run in two modes, explore or obstacle. Explore reports all objects, obstacle only those in front of the user. This is the hardware configuration. It exists a drone, a stereo camera, receiver, and then transmitter, digitizer, and the mobile device. In terms of software, there's a number of components after data collection, pre-processing, including depth and disparity calculations. User detection takes place using deep learning, followed by object detection, and if the object is determined to be of interest or an obstacle, it's reported to the user via text-to-speech. User heading is defined as finding the user and their direction, which is important in obstacle mode. We've set up a series of 8 classes which mimic the directions of a compass: north, northeast, northwest, south, southeast, southwest, west, and east. And these are the classes we use. We've developed a convolutional neural network based on MobileNet that uses separable depth-wise convolution, which is more suited to running on a mobile device. We've modified it in a number of ways, including allowing for RGBD, as well as changing things like stride. So let's look at a demonstration. We'll begin by looking at it running in Explorer mode, where it finds all nearby objects. Here you can see the users detected in blue. The green box is a 2D representation of the volume area that we're looking at, and the depth is based on the actual user depth. You can see the cars in the back are not always detected as being of interest. Here you can see some transmission issues, another issue with the drone, and especially something along the lines of a hobby level drone we have difficulty with. Moving on to obstacle mode, this is finding nearby objects but in the path of the user. The green box represents their path. Here you can see the user initially in yellow is then the person detected in red indicated that they were an obstacle, and as they moved through the scene they became yellow. So they're facing, you can see the yellow user again is not within the green box and is rejected as a possible object or obstacle. Okay, here we're continuing on. There's a person in the back again detected, but not accepted as a obstacle. It'll be highlighted in red when you actually see them. Because they're walking in the same direction and not right near each other, that person in the background is not considered an obstacle. I think in this sequence, the user there in blue is walking towards a car eventually. And the green box is changed based on the classification, like whether they're east or northeast. Here's the red box that signified that the car at that point was considered an obstacle. Now they've turned around, so the green box of interest is there. As you can see, there is issues that our use of a pre-trained COCO model does not always detect the objects in the scene, and this is one of the things that we're currently looking to develop a better object detector than some of the pre-trained ones that are out there.